Welcome the last speaker of the session from David and Simon. The title is Contrafactives and Learnability. Could you please start?
Thanks very much for joining us for this session. So David and I will present jointly. I'll do the first part and then we'll switch to David in the second part. So what we'll be talking about today is a new semantic universal proposed in work by Richard Halton. Richard Halton proposes that there are certain verbs that are missing from natural languages across the world, in particular what he calls contrafactive verbs. And contrafactive verbs are meant to be the mirror image of factive verbs, insofar as they're unanalyzable verbs that ascribe a belief, but unlike a factive verb, presuppose the falsity of that belief. So a factive verb presupposes the truth of the belief, whereas a contrafactive presupposes the falsity. So no would be a factive, whereas here on the slide you see contra, which is an extension of English, which would be a contrafactive. So a contrafactive would have certain empirical properties, such as listed on the slide. So a contrafactive triggers an inference to a falsity of a belief, and that inference is not easily cancelable. So when we say umut contras that it's raining, there's an inference that umut is wrong, it is not raining. And we can't cancel that inference easily by saying, for instance, that it actually is raining. Moreover, the inference triggered by use of a contrafactive would project from entailment cancelling operators, such as question and negation. So thus alem contra that with one and alem doesn't contra that with one, both presuppose that we haven't won. So the inference that alem is wrong is not cancelled by question and negation. The question for our talk is now, well, factives such as no that presuppose truth of a belief are everywhere. Contrafactives such as contra, which presuppose the falsity of a belief, are nowhere to be seen. Why is that? And we're proposing a partial explanation of this fact, which runs in terms of the idea that contrafactives are just harder to learn than factives, and so are less common across natural languages. Okay, before we get to that explanation and its motivation, and how we've tested it, I'm going to talk a little bit about two supposed counterexamples to Richard Halton's universal that Halton already mentioned, just to give us a better grip of what contrafactives are meant to be. And then we'll turn to the hypothesis and how we've tested that hypothesis. So Richard Halton discussed a number of supposed counterexamples, and I've selected two to discuss today because two have been picked up by the wider literature, and it's worth mentioning that. So the first one, Richard Halton noted for Puerto Rican Spanish, but has been noted in normal Spanish as well now. So creerse, wrongly believe, was discussed by Anvari and colleagues. It's a constituent that is formed from the belief verb creer and the reflexive pronoun se. And it behaves pretty much like contrafactive behaves. So it triggers an inference to the falsity of a belief, an inference that isn't easily cancelable. So for example, Juan creerse believes that Anna is 30 years old and he is right, sounds infelicitous. And that inference also projects through questions. So does Juan creerse believe that it's raining? The inference projects, we infer that Juan has a false belief. But the inference does not project in the predicted way under negation. Indeed, there's a polarity reversal there, which Anvari and all find very confusing. Moreover, creerse doesn't really fit the bill because it's not a verb, but it is a larger constituent formed by syntactically and semantically combining a belief verb plus the reflexive pronoun. And that reflexive pronoun se seems to make similar contributions in Spanish in contexts such as pensarse, and across languages such as French in s'imaginer, and triggers these negative inferences. So we get here a kind of compositional equivalent of something very much like a contrafactive, but not a contrafactive. Another example already discussed by Richard Halton was noted by a bunch of developmental psychologists, and it's Mandarin and Cantonese hiwei, which is glossed by these developmental psychologists as believed wrongly. Now, that too has been disputed that it is a contrafactive on the grounds that, in fact, hiwei, at least in Mandarin, does not carry a presupposition, but a so-called post-supposition. Leila Glass has argued for this conclusion by the fact that hiwei has a much weaker inference than a contrafactive would have. So for instance, people, Yiwei, that she's a billionaire and she actually is not infelicitous. So the inference to the falsity of the belief that is triggered by Yiwei can be cancelled. Now, Yiwei, the inference triggered there does project on the question. So is Lily Yiwei that there's a test tomorrow? The inference that Lily is wrong about whether there's a test tomorrow, there's no test tomorrow, projects. So the falsity projects. But with negation, that inference does not project. So Lily definitely doesn't Yiwei that there's a test tomorrow. The inference to the conclusion that there isn't a test tomorrow does not project. So negation again seems to obviate the effect carried by the supposed contrafactive. So we don't quite have a contrafactive there. And as far as we know, there isn't a convincing counterexample to the generalization that there are no contrafactives. Although, as the examples just noted suggest, there are expressions that are pretty damn close to being a contrafactive. In particular, TRC, although that's compositional rather than just a lexicalized entry. So what is our hypothesis in order to explain the asymmetry we find between factives and contrafactives? The hypothesis we have is that contrafactives are harder to learn than factives. And that explains why we don't find lexicalized contrafactives in natural languages, in part because of the following guiding idea that was developed by Shane Strana-Frelkeld and Jakob Simonek in a bunch of papers. So the idea is that languages have words for meanings that are easier to learn and then use compositional methods to express meanings that are harder to acquire. So if a contrafactive was harder to learn, then we'd expect that languages use compositional means to express the meanings that would otherwise be expressed by a contrafactive. So for instance, that's what we find in Spanish. Que se, here we've got a compositional kind of contrafactive, not quite, not fully, but almost a contrafactive. And we can come up with contrafactives even in English. So having a false belief about weather, for instance, is a kind of contrafactive, and other expressions in other languages might work similarly. So by compositional means, we can get to something like the meaning of a contrafactive, but because it's harder to learn, we don't have a lexicalized entry for that. So why should it be harder to learn? Here we apply the factive theory of mind developed in the philosophy of mind by Jonathan Phillips and Aaron Norby. They try to explain why it's easier to acquire something like know instead of a non-factive verb like believe. But their general explanation also applies to the case we're interested in. And the idea is simply that verb like know, a factive verb, represents the way the subject takes the world to be. The subject of the ascription takes the world to be and the way the world is converging. So if I say Umut knows that it's raining, I'm using know and I'm representing the way the subject, the way that Umut takes the world to be and the way the world is as converging. So when I ascribe knowledge to someone else, then all I need to do is to kind of take my own way of representing the world and copy and paste that onto the other person. I take what I take to be true and I copy and paste that onto the other person, because the other person also has a true representation and that needs to match my true representation. With a contrafactive, however, a contrafactive like contra, Umut contras that it's raining, represents the way the subject, in this case Umut, takes the world to be and the way the world is as diverging. After all, Umut has a wrong belief about whether it's raining. And so contrafactive ascription requires ascribing a take to Umut, for example, on how things are, that is inconsistent with my own, because I take that to be false. I take it to be false that it is raining by using the contrafactive. And so my take on how things are, it's raining, versus Umut's take on how things are, it's not raining, diverge. And so we've got to have a more sophisticated capacity for ascribing mental states in order to ascribe contrafactives than in order to ascribe factives. This divergence versus convergence. Now, of course, it's difficult to test this claim that indeed contrafactives are harder to learn than factives, which we've just argued for on general abstract grounds. You can't really do it with children because you'd have to withhold exposure to factives from them, which would obviously be ethically problematic. You can't do it with adults because adults are already exposed to so many factives in their language or their second language that they'd be biased towards learning factives in even an artificial language. So what we've tried to do is to train a neural network to predict the truth value of factive, non-factive, and contrafactive attitude descriptions, and see how that training works, whether there's differences in how quickly the neural network gets up to speed and how accurate it is. And the language that this neural network learns can be interpreted as describing propositions about the relative locations of two objects, plus the attitude taken towards these propositions. So it's a pretty simple language, but hopefully sophisticated enough to give us a concrete sense of what expression type is harder to learn. We've used transformer encoders for this, in part because transformer encoders show a greater convergence with human processing than other types of neural networks that have been used in similar literature, such as feed-forward neural networks or LSTMs. In addition, as opposed to other literature, we'll be reporting results from a larger range of hyperparameters. So we hope that our results prove to be quite robust in light of that. Okay, and with this, I hand over to David.
Hello. Okay. So Simon, next slide. Thanks. So, okay, this is the setup of the experiment. This is all very standard NLP experiments. So I'm doing a hyperparameter search at first to identify the correct hyperparameters or the best hyperparameters for training the neural network, so the transformer network. On a split, that is the training data, I explored 51 hyperparameter settings. That's, I think, a fairly reasonable number given the hyperparameter space. I did a randomized grid search, so I used randomized hyperparameter setting, and I did a 5-fold cross-validation within each of those settings to, again, have some sense of how well the network performs without doing too much overfitting. After doing this hyperparameter search, and I'll give you some results about this search, I'll then do an evaluation on the holdout test set. I'm training on the whole training data now, not doing the cross-validation, and then evaluating on the test set using the best hyperparameter. Next slide. So just as the results from the hyperparameter search, the network, generally speaking, learned whether the sentences are true or false. So it was able to predict the truth value relatively accurately, except for 18 cases out of 51. So 51 settings. In 18 cases, the accuracy never went over 60%. I was below 6%, and that is basically never learned anything really there. It's just some bad hyperparameters. That's quite common with neural networks. And of this 51 settings, in all except 4 cases, the network accuracy for the factive predicate was higher than for the contrafactive ascription predicate. So we already see here that there is definitely a pattern of it just being better on with the factive predicate and the contrafactive predicate. And I have some more pictures on that on the next slide. So you see here, first of all, this is again still from the hyperparameter search, and this is just the average accuracy across these 51 models, including also the 18 models that didn't learn anything. That there's ever so slightly a better performance of the factive one. The mean is ever so slightly high. It's not significant. I mean, I'm giving you here the numbers from the cross-cavalier significance test, but if you just look at the error bars, you're not exactly going to be surprised that the factive predicate is, the difference here is not significant. It's a small number of tests as well. I mean, 51 data points, so it's not exactly surprising that you don't get significance there. But you already see that there is a pattern with the mean accuracy higher for the factive across the 51 models. Next slide. And that gets even clearer when you actually look at the evaluation on the test data. So the differences are very minute if you look at the accuracy on the left, very small. The contrafactive is just 0.2 percentage point lower. But the accuracy is not actually necessarily best to look at, because it's just whether it's above 0.5, then we count it as saying it's true, and if it's below 0.5, we say the sentence is predicted as being false. But the network gives you a continuous value. So if you just look at the accuracy, you're actually missing a lot of the information about the learning that's going on there. So what you actually want to look at is the mean absolute error. That's one measure you might want to look at. And you see it on the left here. And you see there the differences become a little bit also clearer. They're still small. They're still very small if you look at it. But you see that there's a clear step pattern with the error bars now clearly separated, significance test using permutation test. So shows that the p-value is clearly significant by conventional standards. So it's very clear that the mean absolute error is higher for the contrafactive than factive. I should also point out here that the non-factive, so which would be like belief, seems to be even worse. The model seems to be even worse with those. We have good reasons to believe that is an artifact of combining this type of language with this type of architecture. The problem is that I'm giving it both the world and the mind representation, and for the belief predicate, only the mind representation matters. And so the network gets too much information and gets confused by that. We have a second experiment we're running right now where this vanishes because we simplify it. So we have good reasons to believe that this bad performance on the belief predicate is just an artifact of the architecture. Okay, next slide. Just showing you that this is not just about performance at the end, where the network is just very good on all predicates, but you can also see the difference in the training. So this is again the training on the test data, finally on the best hyperparameters, using the best hyperparameters, and you see that it falls clearly faster for factive. So this is just a loss. The loss for the closed field falls clearly faster, which means it learns more quickly. I should say these are very, very highly smoothed losses. The losses are all very janky. You can see that I smoothed over 250,000 training samples, which is quite high. But it is there. Also, if you take a smaller number, it just becomes much harder to see that there is this case. So there is also evidence from here, again, in the right direction. The learnability is higher for factives and lower for contrafactives. Just a few more things on the next slide about the setup. So there are different cases of truth and falsity to be distinguished here based on our language. So as Simon said, it's about the relation of two objects always, and you can imagine them as being in a grid. So in a 3x3 grid, and there's like a blue triangle, a red circle, and a, I don't know, yellow square. And then the sentence might be the ascribed person believes that the red triangle is above the blue square or whatever, something like that. And if you look into that specifically, then there are different ways of being true and false based on the attitudes, which you can't really balance and have at the same time balanced truth labels. So there's a little bit of an issue there with the setup. So the upshot there is that the factive predicate has few cases of being true than a contrafactive predicate if you look at splitting it up, because it always requires the world and the mind to fit exactly, or to fit in with regard to the ascribed, positions of the objects. While the contrafactive can be wrong in multiple ways, right? You can have a sentence where it's wrong because the red triangle is not in this 3x3 world at all, and you can have a sentence where it is wrong because the red triangle is above it rather than below, or something like that. The position is wrong. So you can't really balance that. And we found that this has some effect on the learning. So there's the difference in these cases that affects it. I don't want to go into too much details. We've run now a second experiment that we not have on the slides where we don't have this problem and the results are comparable. So I just want to point out that there's this issue which has to do with the learnability, but it's not the only cause for contrafactives being harder to learn. Yeah, so next slide. So just to summarize the results, I know I've gone through them very quickly because of the time constraints, but I'm happy to take questions later. There's a significant difference between accuracy of contrafactive and factive predicates. Actually, the MAEs, the one where we have a significant result, I should say, not the accuracy. It is small, but it is there. And most importantly, it's quite reliable across all the different measures we looked at. It is there if you look at the loss over time. It is there if you look at the hyperparameter search. Yeah, it's not significant there, but it's also directionally the same way. And it is significantly there if you look at the MAE on the best hyperparameter setting. So it's really there. The caveat with all hyperparameter settings, obviously I just I looked at all hyperparameter settings for the search part and considered all the MAEs there, and then for the test set, I just used the best type of parameter settings. Yeah. And I think I hand over to Simon again.
Yeah, so in conclusion, what we've shown with these experiments is that it is significantly harder to learn for our neural network, significantly harder to learn contrafactives than factives. And we don't take this to be the explanation of why there are no contrafactives. It's at best only part of the explanation, but we think it is indeed part of the explanation of why there is this asymmetry between factives and contrafactives, why factives are so common, whereas contrafactives are nowhere to be seen. Thanks very much for listening.
Great. Thank you for the talk. And the question from the floor. While you were thinking about the question, just a quick question from me. Okay, what kind of data did you use? So, what is the content of that data? You just skipped it, right? So I'm wondering what the neural network learned. How
Right,
did
okay.
evaluated here?
Yeah. So the neural network sees an artificial language and representations of the world and the mind. So it's a transformer network. It gets 3 sequences as its input. The first sequence is just an artificial language with something like contra red square above blue circle, or something like that. And then it sees a representation of the whole grid with all objects in that grid. So there would be 3 objects in the grid, and it would and then it would see another representation of the grid again, which would be then the mind representation, right? So one of these representations of 2 grids, one's for the mind, one's for the world. What's the actual case? What does the person ascribe, believe to, or hold to be the case, according to the
you said that what is the name of the word? Contrafactives involves the presupposition, right? How do you ensure that certain information included in the contrafactives is the presupposition? You need something more complex.
Right. I mean,
that dealt with the assertion part.
Maybe I can address part of this question. So I think the way that we're thinking about it is that presuppositions are rather hard to operationalize. So what we've effectively operationalized is the entailment component of the presupposition. So the fact that the inference to the falsity is not easily cancelable, like with and it actually is. And so the kind of component where it presupposes information in the common ground, that's something that we can't really model easily with the neural network as it is. So we're just focused on this entailment.
Okay, so
the entailment contrast is still there between factives and contrafactives.
I understand it like, well, if you have a certain data, then there is other data which with negation on top of that or something like that. And still projects the presupposed content. Is that the right understanding? Maybe.
So, yeah. So we haven't modeled the effect of negation or question on an ascription with the neural network. So the neural network is just trained with ascriptions in unnegated and unquestioned environments. Okay. So it just sees subject contrafactives, red square on top of yellow triangle. And it never sees things such as does subject contrafactive red square on yellow triangle, or subject doesn't contrafactive red square on yellow triangle. So those kinds of sentences the neural network is not trained with. The neural network is trained with just the bare ascription.
I see. Okay. So I think I warmed up the audience. I'm waiting for the other questions to come. Okay. Michiru-san, could you please unmute yourself?
Hi. It was nice to think about contra. Well, I thought one of your graphs showed that non-factives are harder to learn than contra, if I didn't misunderstand. And you said the reason why contra doesn't exist is that because it's harder to learn than factives, like no. But non-factives are even harder, right? But they exist as lexical items, like believe.
Yeah, I touched on it quickly, but I obviously very, very quickly. There's a reason to think that that's just because of the way I set up the network. So the way the network works, and as I just mentioned, is you get 3 sequences, and the first sequence is like this descriptive sentence, contra red square over blue triangle, and then a representation of the grid as it is in the world, and then a representation of the grid as it is in the mind of the person the attitude is ascribed to. The problem is, in belief, only one of those 2 representations matters. The representation that is ascribed, the one in the mind, right? The grid representation for the world is irrelevant for belief on a non-factive. So basically, the neural network gets a completely useless information for a third of its input, and it gets very confused by that. Now, I think that's just that's just a simplification of the model that we do this. I think realistically, the way we would process this is that there's some filter, there's some gating mechanism such that we blend out the world information when we evaluate description of the mental states. So it's just our model doesn't include it. We strongly believe that this would address the issue. It's not an easy thing to implement such gating mechanisms in neural networks. But we have another experiment also coming out where we use simpler representations, and then we see it vanish because there's not as much misleading information coming in all the time. So basically, it's a result of a simplifying assumption of the model, which we know to be false, or which we can confidently suspect to be false.
So you're saying that the data doesn't support that support the reason why non-factives exist. Okay.
Maybe I can add to this. So we're not claiming that the difficulty or the difference in learnability fully explains why there are no contrafactives, but there are factives. There are going to be a variety of other factors. So the difference in learnability really has to do with like how easy it is to acquire the semantic value of a contrafactive and factive, but it focuses very little on various pragmatic and syntactic reasons why contrafactives might be harder to acquire than factives, for instance. It also doesn't focus on various benefits that we might get from having a non-factive in the language. So non-factive in the language might be extremely useful in ways that contrafactives and factives aren't, precisely because with a non-factive predicate, we can be very neutral about whether something is the case or not. So we don't need to have representation ourselves that we can copy and paste, or we can treat as inconsistent with the representation of the other person. So there's a case to be made that even if a non-factive was harder to learn than a contrafactive, there'd be other reasons that would outweigh this and that would motivate having a non-factive in the language. Yeah, I hope this addresses your question.
Different reason, lexical reason makes it. Thank you. Yeah.
Okay, good.
So, of course, thank you for your talk. I was wondering, because you displayed your results using mean squared error, I think, of course, well, it reflects the accuracy, and it's pretty obvious that it will. But I was wondering, because the task is of binary classification of true threat value for each sentence, if you maybe investigated F1 score to maybe see the difference between false negative and false positives, for instance, of your predictions.
Did I do an F1 score? I think I did, and it was, yeah, I'm looking at it right now. There's no difference between the F1 score and, or there's basically no difference between the F1 score and the accuracy. If I just treat it as a binary classification, which is why I just stuck with the accuracy. Also, just to clarify, because you said I used to mean squared error, I actually used to mean absolute error, which is kind of important because the differences are very small. And if they were that small with the squared error, it would be even smaller in a way. So it's kind of important to notice there's actually an absolute error.
Okay, and maybe also to know if because you have a synthetic vocabulary and language, I think it would be most convenient to explore the attention layers produced by your neural network, because you can perfectly manipulate the vocabulary, so you know what to expect before seeing the values. That is like a small recommendation.
Yeah, you could try to understand it better with the attention, looking at the attention if you want to actually interpret it. It gets a bit tricky. I mean, this is a multi-head attention with multiple layers of attention, right? As a transformer. It's not like one layer of attention and you can just read it out and be like, oh, this is important. This is going to be a bit trickier than that. But yeah, there might be something there. Yeah.
Thank you.
Okay. Let's thank the speaker again. Thank you very much.